What's up guys, welcome back to another video here at Chief Academy, and today we'll be going through similar shapes with lengths. Please like and subscribe if you haven't already, because I promise you, it is this easy. Our learning outcomes for today is to understand what similar shapes are, and to understand what the scale factor is and why we use it. It's also to solve similar shape with lengths exam questions. So, what are similar shapes? Similar shapes are enlargements of each other using a scale factor. All the corresponding angles in the similar shapes are equal, and the corresponding lengths are in the same ratio. In this lesson, we will focus on solving similar shapes of lengths exam questions and understand how to use the scale factor. As we stated before, similar shapes are enlargements of each other using a scale factor. All the corresponding angles in the similar shapes are equal, and the corresponding lengths are in the same ratio. With GCSEs, you'll get asked about similar triangles most of the time, as is a sector of the topic of congruency. In order to find a missing side in a pair of triangles when you are not told that the triangles are similar, first, you use angles facts to determine which angles are equal. We draw the triangles side by side, decide which side are pairs of corresponding sides, find the scale factor, then use the scale factor to find the missing length. The scale factor is what you've multiplied or divided by to get your answer. For example, to get 15 from 5, we have multiplied 5 by a scale factor of 3. So we will use this with all the other angles in the triangle. We will now go through an example of similar shapes so you can understand what I mean by the scale factor and with a triangle. Once again, it's that time to have a go at some Maths Genie exam questions. Have a go, pause the video, and then pause when you've done. So, with our first question, AB is parallel to XY. The line AY and BX intersect at point P. AB equals 6 cm, XB equals 12.5 cm, and XY equals 15 cm. We are asked to work out the length of BP. As we have been told, AB is parallel to XY. So this is our similar length, as they're both parallel to each other and they are both the base of our triangles. So, what do we times by 6 to get to 15? We work this out by doing 15 divided by 6, which simplifies down to 5 over 2, which is 2.5. So 2.5 is our scale factor. And here, XP and BP are our similar lengths. So do 12.5 divided by 2.5, which will give us BP. So BP equals 5. With similar shapes, you'll need to make sure that you can see the separate shapes, as you could have triangles in triangles, which you'll have to see. By what I mean by this, you could have a big triangle and a small triangle inside of it, and then you have a triangle, and then you have, say, a quadrilateral. You just need to see that the big shape overall is a triangle, and then that is a similar shape to your smaller one. Similar shape lengths is the first part of similar shapes, as you'll learn about areas and volumes if you do the higher paper, because area and volume is a grade 6 skill. So you won't do this if you do foundation, but if you do higher, you will learn about areas and volumes. So it's good to get to grips with the scale factor, because the scale factor has a lot to do when you use area and volume. Here is another exam question for you to have a go at. Have a go, pause the video, and unpause when you've done. So, in our first question here, BE is parallel to CD. ABC and their ED are straight lines. AB equals 4 cm, BC equals 6, BE equals 5, and AD equals 4.8. Part A of the question, we are asked to calculate the length of CD. If we can see, ACD is one big triangle, and ABE is also a triangle. So the base of ABE, which is BE, is similar to CD. Now, if we calculate the big length of A to C, and we use that against A to B, we can work out the scale factor, which can then times by 5 to work out CD. So, if we do 6 plus 4, we get 10, so this is our big length. We then divide it by 4, because that's our small triangle length, and we get 5 over 2. So 5 over 2 is our scale factor. Now, if we do 5 times our scale factor of 2.5, which is 5 over 2, we get CD, which getting us CD equals 12.5. Part B, we are asked to calculate the length of ED. As we can see, we see ED, if we times 4.8 times 2.5, we'll get 12, which is AD. Because we've already got AE, we don't need to work out ED. Then if we do 12 minus 4.8, we will get ED. So our final answer for ED is 7.2. Here are some of the hardest exam questions you'll probably be asked as similar shape lengths. Have a go, pause the video, and unpause when you've done. So in our first question, AB is parallel to DE. AEC and BCD are straight lines. AB equals 6 cm, AC equals 8, DC equals 13.5, and DE equals 9. Part A is a question we're asked to calculate the length of CE. So, as we can see, DE and AB are parallel, and both are bases of our triangles. So if we do 9 divided by 6, which cancels down to 3/2, we can get our scale factor. Now if we times 8 by our scale factor of 3/2, we will get CE. So our answer for CE is just 12. Part B, we have to calculate the length of BC. Now, as we already know 13.5 is D to C, we just need to divide that by our scale factor to work out CB. So 13.5 divided by 3/2 gets us to an answer of 9. Now, in our second question, AB to AC is in the ratio of 1 to 3. Part A, we have to calculate the length of DC. Now, as we know the ratio is 1 to 3, our scale factor equals 3. If the ratio was 72, the scale factor would be 7/2. So we do 4 times 3, we'll get CD, so CD simply equals 12. Part B, we're asked to calculate the length of BC. Now, as we know the ratio of AB to AC, we can find that AC minus AB to get BC. So 1 to 3 is simplified of 5 to 15. We do 15 minus 5 and we'll get BC. So BC simply equals 10. And that, ladies and gentlemen, is the end of today's lesson. I did say it was that easy. Thank you very much for watching. Please like and subscribe if you haven't already, and I'll see you in the next one. Goodbye.